good day, everyone. Happy to welcome you to the panel on BVLOS operations and also how data and data-driven services can enable BVLOS operations. And we've heard in the previous panel that this type of digital infrastructure gets more and more relevant. We see more and more BVLOS operations taking place, and now we have a bit more the industry perspective and also the regulatory view on the topic, and happy to welcome all of you. But first of all, Esther, Lorenzo, thank you a lot for this great event. I'm really happy to be here. The third time in a row we're participating, and it's an amazing setup, so I like it a lot. And also dinner, perfect view, Barbara, so thanks a lot for having us. Yeah, before starting with each panelist, I'm happy to provide you a short overview of who we are at Unisphere, what we are doing, and then each panelist has the opportunity to say a few words on what they're doing. So what you see here is basically our core technology is a simulation technology. We create a digital twin of flights by having performance modeling of drones, incorporating digital elevation models, high-resolution weather data. And what this basically does is it's automating pilot tasks. So we can do flight planning, energy prediction, flight time prediction, weather risk assessment, but very technology-driven in always looking at how can we further automate flight operations. And on the next slide, that's just a short overview on where we are active. So Unisphere, we are around in the domain since 7 years. We're working with vertiport companies, supporting them in site selection. We're working with drone companies in flight operations. We support eVTOL companies, for example, with business case evaluation, predicting service availability. And also what we heard in the last panel, these high-altitude platforms is still a topic. We're also involved in doing some flight planning activities there and data analytics. And that's a bit of an overview on Unisphere, and now I'm heading over to Thomas.
Yes, good morning. My name is Thomas Neubauer, co-founder and CEO of Dimetor. And I would like to start with a short quiz. So the question I have, subject to the topic, is when was the first reported UAV BVLOS flight in history? And who was the UAV operator? And what were their key challenges? 1980 Israel. Okay. Anybody else? 1927. Others? Okay. It has been the 15th of July, 1849. And that was actually reported. It was conducted by the Austrian Navy. Yes, and that's not a joke and a typo by the time that sort of thing existed. But the interesting thing is the biggest problems they actually had were they didn't have any data for their 6.5 kilometer BVLOS flight. For example, no information about wind. And it showed that their C2 connectivity was not really adequate. So clearly they didn't get a compliance with OSO 13 in SORA. So the missing of digital infrastructure and the missing of information about the performance of the digital infrastructure led to a catastrophe. Essentially, they bombed their own lines. I'm Austrian, I can say that, so that's fine. The good thing is that has been solved, and this is how we are coming in and what we are providing. That is on the next slide, because today we have the digital infrastructure. It's called mobile network and satellite providers. And what we are providing with our software platform is actually we're processing data. We're processing data between the telecom infrastructure and exchange that with the aviation management and flight management systems. So for example, where in the airspace do you have sufficient connectivity or not? What is the number of people on the ground? And that is dynamic because, census data doesn't cut it. Probably nobody here in the room is living in this political district in London. So census data, you're just invisible, but your mobile phone data knows. In addition, providing alternative sources for positioning with cellular infrastructure. And last but not least, qualifying, is your GPS signal actually correct or not? Because if your GPS signals are spoofed, which happens more and more, you're in big trouble. So providing that information is what we are actually doing. And talking about connectivity as a great example, what we do with Airborne RF, that's the solution we provide, it's assuring both safety as well as the business. Because I believe the biggest business opportunity in drone delivery is data. First responders, visual inspections, survey, etc. It's all about data, and telcos are delivering that. It's a core business. That's why we see more and more telcos engaging, delivering the infrastructure and the data. And that's why it's important to get them on board, to get the authority approvals and to deliver the information. That's in order to safely scale. That's my key message.
Thank you, and thanks for the nice story, Giovanni.
Good morning for having me today and in this exciting event. And I am Giovanni Di Antonio, Director of Technological Innovation at the Italian Civil Aviation Authority. And my primary job is dealing with the new commercial space and the development of spaceports. In particular, we are developing the spaceport in Grottaglie Airport in south of Italy and developing the regulatory framework for spaceport and suborbital flight. And then I'm also involved in the CESAR ECO2 project for the integration of aerospace operations, including hubs and commercial space transportation within the European ATM system. And in particular, ENAC is the solution leader for the integration of supersonic, hypersonic, and suborbital flight. And finally, I'm also in the chair of JARUS, and so you can see that it's my work is pretty funny. And yes, and here I would like to contribute to this discussion at looking at from the high. And for sure, we have said that we need a strict, tight cooperations between industry and the regulators in order to enhance BVLOS operations at scale. And of course, the job of the industry is to highlight the needs in terms of what is needed to regulator. We need to understand from the industry which are the industry's needs. And the role of the authorities in developing these operations based on the data, in our opinion, is to foster and to guide the digital transformation of the utilization of the data and of the digital infrastructure. As a matter of fact, according to our national strategy for advanced air mobility, one of the goals was to the creation of a single entry point, a digitalized entry point, to digitalize the processes of the public administrations, including the authorization. And following that object, we developed a digital platform which is named HyperTwin under the project of named Digital Twin for Innovative Air Services, which is based on the data fusion for different sources, open sources, private sources and institutional sources, and provide some important services, for example, data-driven risk assessment for pre-application of operations in order to speed up the authorization phase, a platform where the different authorities can dialogue together, and where the processes can be, the administrative processes can be done in a digital way. And finally, it is also an environment where it is possible to test future use cases in the context of a regulatory sandbox. In the first phase, we are going to activate this digital platform for strategic purposes in order to carry out pre-application risk assessment. But in the second phase, we would like also to utilize the platform for the continuous management during the operation, benefiting from real-time data. And this is a platform that uses artificial intelligence, of course, and in particular machine learning, both supervised and non-supervised, and will be launched officially at the end of this month in Italy. It is a project carried out by Civil Aviation Authority in cooperation with the digital transformation offices of the Presidency of the Council. Finally, how to cooperate has been evoked many times this morning. For us, the regulatory sandbox approach is very important, and we have also developed a specific regulation in Italy to make this feature structured. And let me say, we have been following the example and the experience of UK in this context. Thank you.
Yeah, thank you, Giovanni and Andrew.
Awesome. So my career has been a little bit unique. I've been integrating drones beyond visual line of sight into the U.S. national airspace for literally the day I got out of college. So for 17 years, that's been my job, and it's taken quite the path. So when we're talking about beyond visual line of sight, applications and how to get there and how to work with regulatory authorities, we've kind of seen a lot. Coming out of the DoD, doing defense contracting, getting Army drones flying beyond visual line of sight as they came back from Iraq and Afghanistan. We then moved over to the commercial space and realized there was a pretty big gap in what the commercial industry was doing versus what the FAA had made us do for the military. And so some of the things you heard today is like kind of the tech meets aviation. We realized that there was this problem of safety assurance. The policies, the standards really didn't match up to what technology was being brought to the table. And so we looked at how do you actually create an operational safety assessment or operational safety assurance in real time. And so that's really what started. We started ResilienX, a company I'm a co-founder and CEO, and we started that 6 years ago to address that. We said, okay, if the technology companies are bringing lots of innovative technologies, can we add a layer that addresses the safety and resiliency of these ecosystems that the FAA or the regulator is going to actually adopt and care about? From there, we had groups coming to us wanting to help us build a system of systems that enables beyond visual line of sight in regional areas, such as New York and North Carolina. And we said, okay, well, yeah, we'd love to help. And so they gave us contracts to actually do the systems engineering. So we've done a lot of model-based systems engineering, understanding what are the requirements, how do they trace to all of the regulations, how do they trace to the standards, how do you understand what your system actually needs to do from a performance and functional perspective. We then had the Air Force come to us and say, well, it's great that you guys are designing these things, but we need you to actually build it as well. So we started doing a digital operations center for remote operations for beyond visual line of sight applications. And we're about a year into that program. And what we've seen is what a lot of people on these panels have talked about and what we've heard in conversations is that the industry just really isn't scaling. You have this discrepancy where you have the technology, but you have not yet got to the point where people can either afford it or people have enough operations to justify it. And so you have this kind of weird gap where either you've put a lot of money into your own vertical infrastructure, which you've seen the Wings and the Amazons of the world have done, or you're a small operator and it's really difficult to get to a beyond visual line of sight operation. And so that's kind of our new thing is how do we address that? How do we actually enable scale? And I actually don't think it's a regulatory problem for the most part. One unique thing about what we're doing in Syracuse, New York with New Air, who's in the room, is that we have 240 square miles of beyond visual line of sight operational area. You can come and fly drones commercially, not especially for DFR or with special restrictions within the region. And so what enables that is the infrastructure, both the physical and digital infrastructure. So a lot of what I haven't really heard as much as I would have expected in some of these panels is the idea of a safety case. Really, if you want to fly beyond visual line of sight, you have to prove to a regulator that it's safe. And that's really, how do you put together a safety case? What are the risks in your operation? How do you address those risks? And if you can address those risks, and I'll speak from a US perspective, I don't know if this is going to be one-to-one with Europe, because we don't do as much here, but in general with the FAA, if you can show them that it's safe, you can generally get a waiver to fly beyond visual line of sight. If you can show them that it's very safe in a region, they're going through what's called an NTAP program, near-time approval process, which is saying, okay, well, if you proved it safe with one operation, I now believe you that you can stamp it out and prove it safe with lots of operations without going through all of the same aspects. And so when we look at beyond visual line of sight, a lot of times we're looking at air risk and ground risk. I put a few things on the slide here that obviously not comprehensive, but more or less don't hit stuff in the air, don't hit stuff on the ground, you have a fairly safe operation. So you look at, well, how do I do that, right? What do I need to put into place from a technology perspective or procedure perspective to not hit things in the air, not hit things in the ground? So a lot of times you need some kind of surveillance. That's not very different from traditional aviation, CNS, right? Comms, nav, surveillance. Weather is a big one with drones. Obviously, they don't fare as well with high winds or maybe in really adverse weather conditions. And so when you look at the infrastructure necessary and the data coming off of that infrastructure and the digital infrastructure that processes that data and interacts with all of the different systems going on and at scale, it gets complex and there's a lot to it. And so what we've really seen over the years is that we understand the infrastructure and the systems that need to be put in place for beyond visual line of sight operations. What has been a harder nut to crack, I'll say, is that the business models don't support that. So you have businesses that know that if they invest $5 million, they can fly beyond visual line of sight, but there's not a business reason, they can't make money that way. And so in the US anyway, we've been really pushing this regional beyond visual line of sight concept where a region invests and brings lots of businesses and then can start to aggregate the use cases and then support the business case that puts out the digital and physical infrastructure for beyond visual line of sight operations. Take it away.
Thomas?
Brilliant, thank you. Thanks above all to Esther and Lorenzo putting this event on. I think it's one of the best events of the year. Well done. My name is Thomas Jimenez. I am the market director UAS for Kongsberg Geospatial. Those of you who don't know Kongsberg, Kongsberg is a large Norwegian defense and technology company. We're broken into 4 main verticals. We got defense and aerospace, maritime, digital, and then subsea work under discovery. So we report to our defense parent. And Kongsberg Geospatial, we specifically work on building situational awareness or geospatial visualization tools, largely in the defense space, but also less known, we do a lot of work in the commercial air traffic space. So the primary tool that we build is a mapping SDK called TerraLens. And TerraLens is widely used in a bunch of different applications. In terms of commercial air traffic management, some of you may have seen images of our remote towers center. Well, I should say Avinor's remote towers center in Norway in a town called Bodø. And at the moment, there's 15 towers that are controlled remotely from all around Norway, controlled in one room. So Kongsberg led that project along with Indra. And just recently, we won the DATS project for Canada. So Canada similarly, and it's going to be a far larger project. It will be the largest project in digital towers in the world. When delivered, it's over 35 years, north of 70 towers, and will provide digital towers for the entire country of Canada. So that all of those systems run on TerraLens. And then focusing down on my line of work, I work specifically in the UAS side of things. So we developed Iris Terminal. Iris Terminal was developed originally it was spun off from a defense tool, the NASAM surface-to-air missile fire control system. It then got repurposed in 2017 so as to be able to use it with UAS. I'll be quite sort of clear here. It's an only enterprise product. We're often associated with defense, but Iris Terminal is only for enterprise. And so my job is to work with UAV or UAS operators, DSPs, so as to try and largely in the US and Canada, we don't do much work in Europe at this point, to try and help them enable that beyond visual line of sight. And we have the success already today. We did a webinar some time ago, and you started the webinar rightly so by saying, listen, BVLOS is done. It's BVLOS at scale that we're trying to achieve here. So a lot of our clients, some of them with deeper pockets than others, are able to basically build very effective proof of concepts. But if we're going to do this at scale, it's not going to be based on individual operators or DSPs deploying their own sensors and equipment, because it's not scalable. So I think the discussion that we need to have is work with large infrastructure owners. That could be utilities, that could be companies like Crown Castle, that could be telecoms companies, and really leverage their infrastructure so that the smaller players in the market, not the Amazons, the Wings and so on, can also play and basically buy C2 as a service. They can buy traffic monitoring as a service. They can buy weather data as a service and make it affordable so that the whole market can come and play. That's my main role. I work very closely with those operators, so as to try and help them, work with the regulators. Ultimately, we sell a regulatory enablement tool, and we got to try. Their success is embedded in regulatory success. Thank you.
Thanks, and perfect ending of the introduction, because scaling is really the question I want to talk about. It's so one example from Unisphere, we are having customers in very different countries, and these countries, the weather data is very different. So you have sometimes radars available, do you have sensor data available, sometimes you only have model data. The model data is different in each of the countries. So offering a scalable solution is very challenging, because for our operators, they just see like an evaluated simulation. How do they understand the difference in quality? How do they understand what is available? How much can they trust? And if we take it one step further, if we go to more automation, how do we handle this? Because all this information needs to be kind of evaluated and transmitted for the automated decision making. And I was wondering if you can share a bit, where do you see either technical or regulatory challenges in this scaling above states, above countries? Because I think the availability of data is quite of a big issue, which is not always the same depending where you operate. So maybe with telcos, you're working with very different ones across Europe. So
I should add that I'm actually also leading a global initiative for harmonizing interfaces between the telecom industry and the aviation industry. And we're here in the building of GSMA. So we initiated that back in 2018. So from 2019, we started an initiative that is called Aerial Connectivity Joint Activity, because telecom has been, or cellular has been perceived a safety risk for a long time in aviation. Switch off your mobile phone, you will hear that when you fly back. But these days, it's considered a necessity for safe operation for drone operations. So it has been quite a U-turn. And in order, because historically those industries had nothing to do with each other, we had to build interfaces that allow not only provide the data, but also make it acceptable on the other side. And that is where we have seen, when it comes to data integration, a lot of effort. So in these initiatives, we have about more than 60 companies actually actively contributing on a global scale, because you have global, always global drone operations in most cases. So you want to deal with, any cross-border or operation in any of the countries, in Europe, for example. You want to make sure that you get the same level, the same quality of data from each and every telco in each and every country. And the same way the telcos want to actually operate, if they're a group, they want to make sure that they can work with their larger customers. So that is a problem that has been solved, I think it's fair to say, due to GSMA supporting that from the telecom side, GUTMA, the Global UTM Association, bringing that together from an aviation side, and having that now making now the next steps in standardizing and making it an acceptable means of compliance to get that checkbox done.
Yeah. Anyone else having take on that?
Yeah, I can jump into that one. So I think the data quality issue is one that we've focused on pretty heavily. When you start to get into automation, a lot of times in traditional aviation, it's very human-centric. There's people watching everything. There's people looking at things going, it doesn't look quite right, or I know that sometimes maybe it's a little fuzzy in this area. Maybe this camera goes out sometimes, it's no big deal. When you start to automate things, when you start to automate the control, when you're trying to do detect and avoid, and you're trying to automate maneuvers, or you're trying to automate yourself around maybe an incoming storm or where there's wind near a building, you really have to understand, how good is the data that I'm trusting. If you trust it blindly, it's not great. And frankly, the regulators are pretty, they understand this issue. They don't want to see you trusting blind data, especially when you start to get AI and things to the mix. If you have a model, it kicks out an answer, regardless of what your inputs. If you have bad data, if you have incomplete data, if you have misleading data, if the systems sending you data are not working correctly and they're malfunctioning, that data all goes into your model and out pops your answer on what to do. And so understanding the data quality and having real-time data quality assurance on all of those data feeds allows you to automate a lot more. And when we talk about scaling, we talk about getting the business case in place, there's a lot of that is going to be dependent on this automation. And so when we look at, again, the data and what's needed, we look at, okay, how do we how do we monitor and assess the data in real time so that the decisions that are being made in an automated fashion with maybe a human on the loop oversight of many decisions that are happening is not overloaded and it has some trust in the system and gets to a point where the regulator also gains that trust.
Yeah. Thomas, I saw you starting answering as well.
It seconds a lot. I think there's two aspects to it for me. One is the equitable and affordable access to the data, the infrastructure in order to do it, but then obviously the safety side as well. At the end of the day, most DSPs and most operators are trying to run a business. You need an ROI on this somehow. On the other hand, the FAA is basically a safety agency. So we've got to try and meet in the middle and prove to this safety agency that we can do this in a way that is both safe, but also do it in a way that it's not so expensive that there's no ROI in the business to start off. And that's that fine balance I think we're trying to achieve.
Yeah. If I may add from the regulatory perspective, indeed it is of paramount importance to rely on quality of the data and their reliability. That's why in Italy it was the regulators in cooperation with other state agencies and departments that developed this kind of digital platform. And in order to ensure exactly the quality of the data and the maintenance of the platform. And in addition, it is also our intention to qualify the platform from an independent body. The platform will be qualified by our Airspace Research Center in Italy. So, but it is true that in order to be used and exploit the data and infrastructure has to be qualified and recognized by the regulator. Otherwise, they are not used.
Yeah, and I think it's in aviation generally an interesting topic because like if you look at the conventional aviation, they stick a lot to the certified authorized data. Like if I talk about weather, for example, we have to use for some use cases the World Aviation Forecast weather data set, but we know that for specific operations, there's much better high resolution forecast available. So what do you want? Do you want like best available data? How do you ensure that it still match a certain quality standard versus authorized data, which is often the case in conventional aviation? The takeoff is based on a METAR. So the pilot looks at this standardized authorized format. And I think on one panel yesterday, it was also like the drone industry is kind of an overall sandbox for conventional aviation to test these new technologies and learn what might be also be applicable in future there, because we have a lot of progress, but it's slowly adopted in aviation. But it's, yeah.
The weather one's a good one. The recent ASTM standard is trying to move away from that, right? Right now in traditional aviation, you generally trust the data because you've spent an absolute fortune on the system and the design certification and qualification, and then what comes out of that system is largely trusted. Well, in this world that we're in now, a lot of people want lots of data from anywhere, the best sources. Maybe the best source is from a camera on a sidewalk, and it tells you if it's raining on the block that you're flying. That's great, but that camera wasn't certified, right? So what you'd really like is a way to actually certify the data at a data level and not necessarily rely on the certification of the equipment that's providing the data.
Yeah. I agree. I think that's an interesting challenge. Like, how do you also ensure if like sensors are deployed by private people, if they place it wrong, so you don't have any, it's behind the garage, so you seem, oh, there's no wind, cool, I can operate, but it's just because of the placement. So how do you ensure this on a performance level? I think that's quite interesting, and we see progress, but it's still slow. But another point I want to touch on, because I think we are already running a bit towards the end of the panel, but no, it's fine. Esther gives me a sign, it's good. So if we talk about more automation, we're also talking about liability a bit. So we're talking about today operators in charge. They are liable. And what do we do if we provide more and more digital services to them and taking over decision making? So what is your view, maybe also from a regulatory and SORA point of view, on these services that take responsibility away from the pilots, but still the liability is in charge of the operators?
Yeah, I can say actually that the unclarity or uncertainty in liability, it's a hard barrier for a technology to get to the market. And we also see this in, for example, in the space domain. And the problem is magnified by the autonomous systems, where different entities concur to design and build and manage the system, and where there are many different functions that at different level of automation which interact each other. And in order to deploy a so-called distributed liability model, which is basically the solution, we need to clarify exactly the responsibilities of each entity. And how to do that, JARUS, for example, has developed a methodology to assess the automated functioning system, and assessing their level of automation, their safety dependence, and their maturity level. And this is an important tool to assess the responsibilities of an automated system. And so this is the only way, in my opinion, to try to set a distributed model of liability, clarifying responsibilities, but not only in technical terms for the design of the system. For example, we have also developed in JARUS the SORA Annex H, which define the responsibilities of the service provider that want to provide services, safety services to the operations. That's another important piece in order to define the liabilities.
Yeah. Any other views?
Well, on connectivity, for example, it's mainly considered a given. We will see in the break that signal is usually not the issue; it's the interference. We're not lacking signal out there. We are limited by interference, and the same thing happens when a drone is actually operating above cell tower altitude height. So the validation for that can actually be done in terms of by means of measurements. And having a live conformance validation that is ongoing is like, providing information about where is your position. That's not rocket science. It's done in telecom industry all the time, and it can be done both from the aircraft as well as from the network. So it's I think these systems are there. The automation is a must-have, because otherwise you just can't scale.
Thomas, I saw you.
Yeah. Sorry, I was just reading my question there. So ultimately, the responsibility, if you went to someone in the USA and said, well, who's the responsibility? The RPIC is responsible is the easy answer. That was based on the early days of how it was all built, and they were very simple systems with point-to-point people flying drones. As the systems become more complex, it's not fair to place undue burden or undue responsibility on that pilot without the systems in between the pilot and the potential conflict or accident being very well vetted. So ultimately it comes down to the safety of that process, and having redundancies, having safety systems in place so that you can pass some more of that responsibility back to this RPIC, who's now using far more complex systems. And I'm also a crewed pilot. It's very clear who the responsibility is, and it's very clear in the event of an accident to be able to decide, was this a pilot error or was this an aircraft error? We need to be able to reach that stage in uncrewed aviation where it's easy to determine whose responsibility it was. And I think that's, it's down to building a lot more software assurance and safety layers in the process between the conflicted aircraft and the pilot.
Yeah. Thank you. So I think it's a sign that they are turning on the questions, and it seems, Thomas, they like your topic a lot. So it's uncooperative traffic is a huge problem. What do panelists consider as the biggest challenge to make all crewed aircraft adopting electronic conspicuity? So any taken on that from your side?
I'm a big believer in that. I don't know. In the US, it's quite different. In the US, inside a mode Civile, you have to broadcast ADS-B. That seems quite simple to me. I speak a lot with the folks at Avionics, and they're very big advocates for it because they sell the systems. But I think that we could solve a lot of problems with simple conspicuity, whether that's conspicuity from crewed aircraft by ADS-B. In the US, they aren't happy to adopt ADS-B from crewed aircraft. Whether that becomes network remote ID, I don't think broadcast remote ID is a suitable solution for it. But if we could have conspicuity across crewed and uncrewed aircraft, we'd solve a lot of these problems and reduce a lot of these costs that the operators are bearing in order to try and make out what's in the airspace that's not broadcasting.
Yeah, I completely agree. We touch point on this topic, knowing the air traffic would solve a lot of other things and also related to the weather, for example. So we talk about how well can we predict visibility, low cloud, and all this, which was not a topic in metrology in the last years, and the models are not really good on that. So either we deploy a lot of very expensive infrastructure, or we just make the airspace visible, and we don't need to take care a lot on, is it still VFR where I'm operating? So I think there's a lot of things that would be beneficial if we reach that state, but it seemed to be different in the different countries and areas. So maybe from a regulatory point of view, Giovanni, what do you think? Is it realistic in near future?
You mean the weather?
No, the conspicuity of the air traffic.
The IDSB, it's in principle a solution, of course, but the question is whether this technology can be used for every types of drones and everywhere, or whether there are limitations to the use of this technology. This is the question. And then again, the reliability, we have to ensure the reliability of this system. No.
I do have a comment on that, because in the lower airspace, of course, the cellular contributions for electronic conspicuity can be also very significant, as you are leaving traces throughout the network. So you know where that is, and it has a different behavior than other participants working on the ground. So you can actually, that can contribute to that. ADSL, so ADSB over light over cellular, is one step that is certainly contributing, certainly not solving all the problems, but I think it will be a multitude of capabilities providing electronic conspicuity. And it's interesting again to see that there's a significant interest in electronics, conspicuity through and via cellular.
Yeah.
I think I'll throw something in there too. I think what we've seen in the US anyway is that this is much more of a policy issue than a technology issue. The traditional aviation and pilots, they don't want it, and they have a big checkbook, and they have told the FAA no, more or less, and the FAA has gone with it. And so now you have alternatives, right? Do you need to put expensive radar systems in, and then again, do you have to figure out a business model that can afford radar? Or do you have to work in a mode Civile where there's already some things in place? So I think this has been a tough nut to crack in the US, and continues to be.
Yeah. So we have 5 minutes left, and I'd like to use the time for one last thought or wish from each panelist. I'm starting with, for us, it would be quite interesting just to get more data. Also, what are really the topics? So is really weather a topic when flying and crashing or having incidents, or is it other things? And we were searching for this a long time, and I came only across one publication in the US which had a look at, I think, 100 or 200 incidents that were reported. The funny thing was, browsing through it, in the end, 8 were caused by kind of weather influence, and 6 times the drone were shot down. So basically, is weather really the main issue? So how big is it? To answer this question from our perspective, we would like to have much more data also from a regulatory perspective. So what are incidents? What is happening? And also fostering this industry learning and sharing, which is in aviation quite common. So you have an incident, everybody is sharing thoughts about it, and we learn as an industry. And I think in the drone world, this is yet not happening perfectly. So we do not know a lot of what is going on in the countries. We do not know about all the drone flights, the incidents, the learnings are not really shared. And that's something we would like to see more and more coming in future, because then we can take actions on that. And we're sure there will be incidents, there will be failures. We will learn from that. But if we don't share, it will take much longer, and it will also cost a much more public acceptance, because there's failure we could avoid. And this is one topic from our side: sharing data, exchanging on data, and learning as an industry, and not like only single companies on that end. Thomas.
Well, from a thought in terms of what should be done or what will be done is, I think the single most important thing is to have a digital infrastructure in the airspace with all sorts of different kind of data feeds that are harmonized. And we see that in some cases it's done through a single CISP, or it's done from a regulatory perspective, but from a drone operator perspective, they have slightly different requests. So getting that data about or getting the digital infrastructure in place and getting information about the performance of the digital infrastructure, providing weather information, providing connectivity information, providing conspicuity information. I think that is one of the fundamental aspects that is required to safely scale operations and also to safely run, for example, approvals, like SORA approvals, asking for dynamic information. Well, then we need to provide the appropriate dynamic data sources to make that an automated process.
Giovanni?
Yeah, I quite agree. And indeed, in Italy, we are trying to build this kind of platform that goes exactly in that direction with the fusion of population density data and airspace structure data and critical infrastructure in different layers. And we would like also to include the weather data and in order to use and real-time awareness of the airspace. But I want to say that this process has to be a step-by-step process. From a regulatory perspective, we cannot put in place everything at the certain moment, but we have to proceed step by step and trying to enlarge the capability of this digital infrastructure by proving it is safe and secure and reliable.
So I'll hit one of these questions to kind of finish off here. I think standards is a big piece of this. We talked a lot about the data and the quality, but we really haven't talked about interoperability. And to the point Thomas made at the start, right? Beyond visual line of sight, you can do it with good data, but to do it with lots of other people at the same time in the same area requires a lot of interoperability. So I think the standards are really big. I think one thing that we need to do in the standards better is actually define the data. Our platform, we have to write a new interface for every single thing we touch, and it is infuriating. Oh, you have a new radar. Well, of course it doesn't speak the same language the other radar does. Oh, you have a new software system. Well, we made up this new interface that you now need to play with. New weather sensors. Well, we don't really do it the same as the last weather sensor. So that's been rough in the industry, and it's time and money. Every single integration is different every single time. It's not even the data itself. It's different protocols, different authentication schemes. It's wild how much difference there can. You'd think at some point 2 people would do the same thing once, and we haven't even found that yet. So I think from a standards perspective, it's hugely necessary in order to get to that scale and that interoperability. My one thing for anyone working standards is to actually define the interfaces, make them flexible, but define a baseline interface so that you can actually have people that integrate with one thing and can integrate in lots of places.
My leaving thought, if you ask my boss what my job is, he'd say it's to sell software. If you ask me what my job is, I spend most of the time working with operators, DSPs, trying to really help them achieve that success. Once they achieve the success, we'll sell more software. The biggest problem I hear from these DSPs and operators is that there's no ROI if we make this morbidly expensive. And at the moment, in the US, it requires systems that are morbidly expensive. So I'm trying to work very closely with them, so to try and understand how we can use our systems of airspace visualization, deconfliction, and so on, but make them affordable in terms of the sensors required. And then go to people like Jeffrey Vincent at the FAA and prove to them that we can do this in a safe way. So that's my balance, that's the thought, and that's what I keep working for every day.
All right. So thank you very much. Nice to see the different perspectives on data, and at one point all of that needs to merge, and that's going to be very interesting. And looking forward to seeing the industry having more focus on that, and not only the drone itself, but all the digital infrastructure around. And thanks for listening to us and having a nice day. Thank you.